We're going to learn about trigonometric identities. So let us explore what is the identity means. Okay, as I told you trigonometric ratios, then I explained the ratio. Okay, then I explained trigonometric ratios of some specific angle. So I explained about specific angle. Then thereafter trigonometric ratios of complementary angle. I explained about complementary angle. Okay. So those videos are really required to understand trigonometric identities. So I'm giving the link in the description. From there you can watch the video if in case you have not watched. So let us understand what the identity means. Identities means simply an equation that are valid for every condition. So what about trigonometric identities? Trigonometric identities means an equation that contain trigonometric ratios, and if the equation is valid for all the theta angle, in that case we can simply say that the equation is an identity. So do you understand this? No, I don't think so. So let me make it clear by taking an example. Suppose I'm writing cos theta is equal to sin theta. Okay, and I'm telling that for theta is equal to 45 degree. Now you are familiar with this thing. Theta is equal to 45 degree. When you put cos 45 degree, it becomes how much? Cos 45 degree is equal to 1 upon root 2. And also in case of sin theta, sin 45 degree is equal to 1 upon root 2. These are your basics. That's why I'm telling these things, so that for understanding and for solving the proof you must have some knowledge. That knowledge will be really very much useful for you to derive the proof of 2 page understanding, because these trigonometric identities are really very much important, and there you will find always a question in your examination, in your board examination. So watch the full video and there is a lot of to learn. So sin 45 degree is equal to 1 by 2. Now I was saying that for every theta this equation must be true, but in this case this equation is true only for theta is equal to 45 degree. So is it an identity? Yes, of course. No, this is not an identity because it is true only theta is equal to 45 degree. So from there we conclude that this is an equation, not identity. So every equation is not identity. So let us see how to derive identities. So for this, we know that trigonometric identities must contain trigonometric ratios, and for obtaining trigonometric ratios we must have right angle triangle. So for that purpose we are making right angle triangle ABC. Okay, and my first step is I am taking an angle theta over the base AB. So which will be the perpendicular? Exactly, BC. And for this triangle I am writing Pythagoras theorem. So look at this, how to write the Pythagoras theorem. Now I want to make this equation in the form of ratio. So for writing the ratio, I have three choices. How many? I have three choices. The first choice is divide both the side by AC square, and we have also second and third choice. We'll soon discussing these choices. So in this case, I am dividing the whole equation by AC square. Did you understand this? Why I'm doing like that? Because I have to make this equation in the form of ratio, because trigonometric identities are depending on the ratios. Which ratios? Trigonometric ratios. That's why we are doing like that. So see it, AC square upon AC square, this equals AB square upon AC square, plus BC square upon AC square. Now you can simply cancel each other. This equals to 1 is equal to AB upon AC, and both are in squared form, so I can take square for once, and then thereafter BC upon AC, again whole square. Okay, now here you can see that AB upon AC, and come to this triangle. Look here, AB upon AC. Now remind of the trigonometric ratios. This is the base, okay, and this is hypotenuse. So Pandit Badri Prasad har har bole. AB upon AC. This is AB, this is AC. So AB is the base, and AC is the hypotenuse. So this one is the cos theta. So I can write cos theta instead of writing AB upon AC, cos theta, and then thereafter, and the square comes over here, you know about it, BC upon AC. So check for BC. BC is the perpendicular and AC is again hypotenuse. So perpendicular upon hypotenuse, what it signifies? Good, sine theta. And now square comes over, so this becomes sine square theta. Now we obtained an identity that containing trigonometric ratios and their sum is equal to 1, and I bet you that this identity is following for every theta. It will be equal to 1 because I have derived this identity. So let's check it. Suppose that this time I am taking theta is equal to 30 degree. Can we do that? Yes, of course. So let us put the value of theta on this identity, and if we get the sum is equal to 1, so we can say that yes, identity is true. So look here, cos 30 degree whole square plus sine 30 degree whole square. So cos 30 degree is equal to how much? Root 3 by 2 whole square, and sine 30 degree is equal to 1 by 2 again whole square. So 3 by 4 plus 1 by 4, this is equal to 1. Wow, we did it. Means the value is exactly equal to 1. So this verifies that this identity is true, and obviously this must be true because we have derived it. Okay, so this one is the first identity, and first identity is written like, first you write sine square theta, then thereafter cos square theta, this equals to 1. So keep this identity in your mind, and if you're working with this identity again and again, it will remind you forever. Understand? So move to next. So as I told you about the choices to make this equation as in the form of trigonometric ratios, we have three choices, in which one choice I have done. Now move to second choice. divide the whole equation by AB square. Okay, so this one will be second identity. So move for it. Let's do it quickly. AC square is equal to AB square upon AB square plus BC square, then thereafter, okay, AB square. Now look here, AC square, AB square, again you can write it as AC upon AB whole square, and this becomes 1 because AB square upon AB square plus BC square upon AB square. Look, again we can write it as BC upon AB whole square. Now we got the ratio. Now let's convert this ratio into trigonometric ratios. So how to do it? You know about it. AC is the hypotenuse and AB is the base. So hypotenuse upon base. Hypotenuse upon base. This is what? Very good. Sec theta. And square is there. So sec square theta is equal to 1 plus. Now BC is a perpendicular. Okay. And AB is a base. So perpendicular upon base is equal to tan theta. Good. So tan theta and square. So now you obtain the second identity. That second identity is equal to sec square theta is equal to 1 plus tan square theta. Okay. So do you think that its verification is required? No, not required. Verification is not required, but let me make this clear that you can use this identity in various forms. The first form I am writing here, just bring 1 with sec square theta, so it becomes sec square theta minus 1 is equal to tan square theta. Now this time tan square theta is standing alone and sec square theta minus 1 is standing alone. So sometimes you need to put that value of tan theta in this form. So from here you can put it simply. Understand? Now as I derived the previous identity, sin square theta plus cos square theta is equal to 1. So let's write this identity in that form. Okay. See, sec square theta minus tan square theta. I am bringing tan square theta left hand side. Sec square theta minus tan square theta is equal to 1. Okay. So this is your second identity. Now please keep this identity in your mind and let's move for the third identity. Now the third choice is divide the whole equation by BC square. So let's do it. Dividing RHS and LHS by BC square. AC. Now can I proceed some direct step by BC and becomes whole square equals AB square upon BC square, but instead of that I am writing this, and thereafter BC square and BC square being divided and they becomes 1. So again use this triangle and write this ratio in the form of trigonometric ratios. So let's do it. AC is what? Hypotenuse, and BC is perpendicular. So hypotenuse upon perpendicular. Look here, hypotenuse upon perpendicular. This is what? Exactly cosec. This is cosec theta. Now you are feeling the importance of those videos for writing these things. Okay, that's why this is the last part of your chapter, because this identity is using everything from the chapter frequently. Understand? So it becomes cosec, the square comes over here, and equal to AB upon BC. Look, where is AB? AB base and BC perpendicular. So base upon perpendicular becomes what? Cot theta. perpendicular upon base is tan theta and the reciprocal of tan is cot theta. So write it as cot square theta plus 1. Now you have obtained the third identity also, because you have three choices only for the making this equation in the form of ratio. So you have now applied all the three. So this one is the third identity. Okay, cosec square theta is equal to cot square theta plus 1. Now let's write this identity in the second form, that is sec square theta minus, I am writing this identity in this form. The reason being their use. Soon I will give you the example and you will feel that why I am writing this equation. Okay, so cosec square theta minus cot square theta, this equals to 1. Now we have done the identities. Now these identities are really very much important, so keep these identities in your mind. So let's move. Now I am taking an example. Cos square theta plus 1 upon 1 plus cot square theta is equal to 1. So this question we are going to prove. Okay, and for proving this question, first of all notice the square. Yes, there is a square. So if there is a square, now we are able to use those identities that we have derived earlier. Did you understand this? I mean to say that those identities like sine square theta plus cos square theta is equal to 1. Okay, and the remaining two identities. So by checking the square, we can know that these identities we can use here. Okay, this is the first step. Okay, note it down. This is the first step. So what should be the second step? Let's take LHS. Okay, so I'm taking LHS. LHS is equal to cos square theta plus 1 upon 1 plus cot square theta. Now look for the cot square theta. Cot square theta also hold an identity. Let me write that identity. Cosec square theta is equal to 1 plus cot square theta. Look here, 1 plus cot square theta. In the place of 1 plus cot square theta, you can write cosec square theta. Surprising? No, not surprising. These are the results we obtained for our simplicity. And now see how it becomes simple. So here you can write this value. Understand? Now 1 upon cosec theta is what? Good, sine theta. So in the place of this value we can write as sine square theta. Now tell me, cos square theta plus sine square theta is equal to 1. Exactly. So this becomes 1 is equal to how much? RHS. And then you will write hence proved. Okay, move to next example. The next example is tan square theta minus 1 upon cos square theta is equal to minus 1. So let us prove. First of all, we'll take LHS is equal to, look, tan square theta. Okay, no problem, I am writing it as, and 1 upon cos square theta means 1 upon cos theta is what? Good, this is sec theta and square is over there, so sec square theta. Now let me write the identity. Sec square theta is equal to 1 plus tan square theta. Is it so? Is it so? Yes, exactly. And look, tan square theta minus sec square theta, you have to obtain this value. So let us see how to obtain this value from this identity. First of all, we'll bring the sec square theta in this side, so it becomes 1 plus tan square theta minus sec square theta is equal to 0. Okay, nothing will left here, it's equal to 0. Now send 1 this side, so it becomes minus 1, and this equal to tan square theta minus sec square theta. Now you got the value, so in the place of sec is tan square theta minus sec square theta, you simply write it as 1 is equal to RHS, and hence proved. Move to next example. I'm taking this question for a reason. The reason is 1 plus sine theta and 1 minus sine theta. Look at these two values, 1 plus sine theta and 1 minus sine theta. Now what they are indicating? They are written like a plus b and a minus b. So right now I'm studying trigonometric identity, and we are moving where? Algebraic identities. So nothing to worry about. These identities are also very much important, and even they are playing a massive role in solving the proofs. Understand? So let us quickly resolve this value, and this becomes 1 plus tan square theta, and thereafter 1 square minus sine square theta. This is what? LHS. LHS is equal to. Okay, now the next step is to find. Now they are in squared form, so now you are able to use those identities. So first of all, look for the identity that contain tan square theta. So I'm writing the identity here. Okay, in this place I'm writing the identity for the tan theta. Sec square theta is equal to 1 plus how much? Very good, 1 plus tan square theta. And for sine square theta, so sine square theta plus cos square theta is equal to 1. But you have to find the value of 1 minus sine square theta. So from here, just you have to shift this sine square theta to RHS. Cos square theta is equal to 1 minus sine square theta. Understand? So this value indicating cos square theta, and 1 plus tan square theta is what? Sec square theta. So let us put in the place of 1 plus tan square theta, sec square theta I'm putting, and then multiply how much? Cos square theta. Cos square theta. Now look, sec square theta is the reciprocal of cos theta. Cos square theta multiplied with the cos square theta. Now they are cancelled and it becomes 1. So 1 is the final answer. Not answer, its proof is done. So it becomes equal to RHS. Okay, understand? Hence this one is also proved. So move to next example. Now the fourth example is 1 minus cos square a and cosec square a is equal to 1. So do you think why we are taking so much examples? The reason being a simple reason. The reason being, when you be knowing the identity, how to use them, so you will be a bit frank with those identities. Understand? And when you frank with those identities, you will be able to use those identities. So look again, 1 minus cos square theta. Now remind that identity. I told you sine square a. Now this time a is written here, so I'm taking it as a. Sine square a plus cos square a is equal to 1, and the requirement is what? 1 minus cos square a. So let's bring this cos here, and it becomes sine square a is equal to 1 minus cos square a. Understand? So in the place of 1 minus cos square a, you can simply put sine square a. So taking LHS is equal to sine square a, and then thereafter multiplied with cosec square a. Now what about cosec square a? It is the reciprocal of sine square a. Do you know this? 1 upon sine square a. In bracket I am writing it. Sine theta is equal to 1 upon cosec theta. Okay, now again they cancel and 1 is equal to RHS, hence proved. Okay, this time I am taking a bit tricky example, and look, 1 minus sine theta upon 1 plus sine theta is your LHS, and sec theta minus tan theta whole square is your RHS. So this one is a bit tricky question, and this type of question is always asked in your examination, so this is really very much important question. But for solving this question, the requirement is you can solve this question by 1 or 2 or 3 methods at least. Okay, so but in basic situation you have to solve this question like this. I'm doing it since you know the formula of a square. Okay, so do you know the formula of a minus b square? So this question will becomes a bit easier for you to open the square. So take RHS. Again I'm saying there is also 1 or 2 method left for solving this question, but this because of his square I'm doing it. RHS is equal to, so open the bracket, you will get sec square theta plus tan square theta minus 2 sec theta tan theta. Now look at this equation, some values are in sec and tan. So the trick is convert all the value in the form of sine and cos, because every value means any ratio can be written in the form of sine and cos. Look how. So sec square theta is what? 1 upon cos square theta plus tan square theta is what? Sine square theta upon cos square theta, then thereafter minus 2 into 1 upon cos theta into sine theta upon cos theta. Now some of you might be wondering that how I'm writing tan theta in the form of sine theta and cos theta. So don't worry about this. Tan theta is equal to sine theta upon cos theta. This is also an identity, and this identity is true for all the theta angle. Understand? That's why this becomes an identity. So need not to prove this identity because there is only 1 or 2 steps involved in this, and you can do this by your own. And if you wish to, so I can do it for you. Just you need to tell me. Equal to, look, cos square theta, and again cos multiplied with cos square theta. So all the cos square theta can be taken together as denominator, and what left? 1 plus sine square theta minus 2 sine theta. Understand? Now the next step is, I'm doing it. Look, this equation 1 plus sine square theta minus 2 sine theta, this equation can be written in this form: 1 square plus sine theta whole square minus 2 times 1 into sine theta. Now you need to put your whole attention on this screen so that you can understand this. And what about cos square theta? So for cos square theta there is an identity to convert it into sine theta, because the requirement is of sine theta. So I am doing all the values in, I am bringing all the values in the form of sine theta. That's why we have to convert cos square theta in the form of sine square theta. Understand? Okay, so see, cos square theta is equal to 1 minus sine square theta. By using the identity we can write it as, so it becomes 1 minus sine square theta. This question is a bit tricky, but don't leave this. Complete the question and try to solve it by your own. Understand? So may I erase this one? I hope you have written in the copy. So let me erase it. Okay, now from here we conclude that this is what a square plus b square minus 2ab. So it becomes 1 minus sine theta whole square. Did you understand this? Okay, this is so simple. What about 1 minus sine square theta? As you put 1 square here, it becomes also an identity, and the identity is a square minus b square. What is the identity? A minus b, a plus b. Okay, so I am erasing it and writing here 1 minus sine theta in one bracket and then 1 plus sine theta in second bracket. Okay, look clearly 1 minus sine theta is here, 1 minus sine theta is here, but having squared form. So what a square stand for? A square means the same quantity multiplied with itself. Okay, look, 1 minus sine theta and then 1 plus sine theta. Okay, now simply they can be cancelled each other, and what left? 1 minus sine theta upon 1 plus sine theta. This is your LHS. So in this case I have taken LHS, so there is a freedom that you can take RHS or LHS. Your answer will not be affected, but remember your steps should be in appropriate manner, otherwise you will not reach to the goal. My goal was 1 minus sine theta upon 1 plus sine theta, and look, I have fulfilled it by using some proper steps. Understand? So we'll make a next video on some more higher questions that are in your previous year papers. So we'll make on a video on that, but for now you have to learn the identities and solve the questions that are very small questions, not like proof. Okay, so I have enjoyed and I hope you too enjoyed. See you in the next presentation.